Looking at trigonometry graphs, and this is using again desmos.com, I just would like to kind of explore, like we've done with the other graphs we've done, what these functions look like and what the different parts of their transform equation show you. So sin graph is repeatable, goes up and down, up and down, up and down, and cosine is very similar to that, also going up and down, up and down, up and down. Now, we can do a few transforms with these. You'll notice that they're very similar to each other. They're just shifted off ever so slightly. Where cosine, we zoom in, cosine starts at 1 at a maximum, and sin starts at 0 or at its equilibrium or its midline. Where you notice here, the x-axis here is kind of like a midline. So if we got rid of cos, we could see that that axis there splits that graph in half each time. It goes up a total of 1, down a total of 1, up a total of 1. So this describes what's happening going over and over again. So they're cyclic. Now if we want to explore A, what the A part does, right now it's set at 1, and we'll just make it bigger. You'll notice that the graph is staying fixed in place in terms of where it crosses the x-axis, but as you make A bigger, the amplitude gets bigger or smaller, so the humps get bigger or smaller, the peaks get further away from each other, and our amplitude is measured from the equilibrium up to the peak or from the equilibrium down. So that's going to be our amplitude, and if you go negative, watch how it's going up here to a peak. If you flop over to negative, you'll notice that the graph goes down first to a trough. So it goes down first to the trough. So get that plane. And here we could say that A is our amplitude, the height of the graph. If positive or negative, we'll swap, kind of flip it over. We'll flip it over. And so a positive sin starts at the midline and goes to a peak. Negative sin starts at the midline and goes to a trough, or a minimum if you want. So that's what we see going on here, and if we take a look at cos, we can get it flopping around as well at the same time. Cosine is the blue one. You'll see that the amplitude has the same thing. As A gets bigger, the amplitude gets bigger. As A gets smaller, the amplitude gets smaller. But if we look specifically at cos, here I have a positive number, and you'll see that it starts at its max. So positive cos starts at max. And if I flop to a negative, you'll see that a negative cos starts at min. Okay. Now similar things will happen with tangent, but it is a totally crazy graph compared to the other ones, and we don't often deal with it. But this is what tangent does. It's got vertical asymptotes and just cycles back and forth between. But we focus mostly on cos and sin. So, looking again at these, let's take a look at the next bit. If I look at changing b, which is inside the equation, this is what I might call the Scrunch factor. And let's just look at one of them again. We'll look at cos this time. If I change b, watch what happens. If I make b bigger, it starts to scrunch it in. It gets really tight together. You get a lot more of the up and downs, so it becomes a lot more rapid, that repeating cycle between max, min, max, min, max, min. It quickens it up. If you make b really small, it stretches it out. So here you see there's a lot more distance between the max and the min, and then back to the max again. So the Scrunch factor stretches the graph or compresses. A large B means very quick repetitions. Okay, so watching that again, compresses it all in, and then starts to stretch it all out again. So our last part, D, which is the part hanging off the end of the equation, like we've seen with exponentials, parabolas, and with hyperbola, the thing added on to the end always is the part that moves it up and down. So D right now is 0, and you'll notice the graph is symmetrical around 0, goes up an equal amount and down an equal amount above 0. But if I change it and make it slightly bigger, you'll notice that the graph shifts up, and as you might expect, if I move it down, the graph will shift down as well. So that's what's happening there. D shows the midline, or what we call equilibrium of the graph, and shifts the graph up or down. And we have positive going up and negative going down. So give a play with these. If you're trying to get to the excellence level of writing your own equations, it's helpful to understand what these different parts of the equations do. But it is actually helpful at all the levels for just understanding and kind of dummy checking that you've done the right thing on any of the problems that they give you.